Hi, welcome to Math Master. This is Saritha. Today our topic is basic proportionality theorem, which is also called as a Thales theorem. Okay, so what is the statement of this? If you draw a line which is parallel to one of the three sides, you take one line, so which is exactly parallel to any one of the three sides. So what will do that line? That line will divide the other two sides in the equal ratio. So we'll see. You take one triangle. This is a triangle ABC. Okay. So these are the sides of a triangle AB, BC, AC. I am taking one line which is parallel to BC. So this line can be like this or like this or like this. Whatever may be the line you take, that must be parallel to the side BC, right? So I am taking one line. So this PQ, this line I am taking, so which is parallel to the side BC. So this is the symbol of representing parallel lines. Okay, two arrows. This PQ is parallel to BC. What happens if this line is parallel to BC? This line divides these two sides AB and AC in the same ratio, which is nothing but AP by PB, which is equal to AQ by QC. See, these are the parts of the side. See, these are the parts of this side AB, and these are the parts of this side AC. So these are in the same ratio. That is what a statement of basic proportionality theorem. So do we need to consider this line is parallel always to BC only? No need, right? So we can take this line, means any parallel line, to other side also. Means you take this figure, means I am taking other side A, B, C. So I am taking AB side, a parallel line to this side AB. See, PQ. Okay. So this line is parallel to AB line. So what it is doing? It is dividing the AC and BC or in the same ratio. See how can we write? CP by PA, which is equal to CQ by QB. Okay. So you can take a parallel line to other side also, which is ABC. So now I am taking a parallel line to AC. So this is a line. This is PQ. Okay. These two lines are parallel. So what it is doing? It is dividing these AB and BC sides are in the same ratio. So how can we write? BP by PA, which is equal to BQ by QC. So if we take any line which is parallel to any one of the three sides, that line will divide the other two sides in the same ratio. Okay, this is what a basic proportionality theorem. Now we'll see converse of basic proportionality theorem. What is the converse of basic proportionality theorem? Converse of basic proportionality theorem. So what is the converse? In the basic proportionality theorem, we have taken one parallel line, so that is dividing the other two sides in the same ratio. So what is the converse of that? If the ratio of the two sides of a triangle are equal, then that time that line is parallel to the third side. Okay, so that is what a converse of basic proportionality theorem. See, you take one triangle. So in this triangle, I am taking one line which is PQ. What it is doing? It is dividing the two sides in the equal ratio. Means if this is X this is kx. If this is y, then this is ky. So what is the ratio of these two? X by kx, which is equal to 1 by k. Y by ky, which is equal to 1 by k. See, these two sides are in the same ratio. If the ratio is same, then this line PQ is parallel to BC. Means the ratio is given. We are saying that line, the line which is dividing the ratio, no, that line is parallel to BC. So we are concluding that PQ and BC lines are parallel to each other. Okay. So from this, if how can we write AP by PB, which is equal to AQ by QC. Then what happens? PQ is parallel to BC. Okay. So this is how we can write converse of basic proportionality theorem. Okay. So you can take other two cases also. Means this PQ line is, you take one time as a parallel to AB and you take one time as parallel to AC. That time you get like this. So AP by PB is equal to AQ by QC, which is from that we can conclude that this PQ line is parallel to the third side. Okay. So we'll see some applications of basic proportionality theorem. We have taken one triangle. This is ABC triangle and this is a line which is parallel to BC. Okay. From this, what can we write? AP by PB, which is equal to AQ by QC. Right? If PQ is parallel to BC, then AP by PB is equal to AQ by QC. So we'll add 1 on both sides. AP by PB plus 1, which is equal to AQ by QC plus 1. So what happens? AP plus PB divided by PB, which is equal to AQ plus QC divided by QC. So AP plus PB, AP plus PB, which is equal to what? AB, right? So you can write AB in place of AP plus PB. AB by PB, and similarly you can write AC in place of AQ plus QC. AQ plus QC. We can write AC, right? AC by QC. So this is the result we have obtained from the basic proportionality theorem. So what it represents? See, what is AB here? AB is a total side. AB is a total side and PB is what? It is a part of a side. Now, if you know the length of the total side and one part of the side, then also you can find out other side or other part of the side. Right? See, AC, this is the other side and this QC is part of the side. Okay. So this is the one conclusion we can draw from the basic proportionality theorem. And we'll see the next one. Okay, we said this PQ is parallel to BC. Okay, so I don't know what are these angles. I am consider this angle as a x degrees and this angle as a y degrees and this angle as a z degrees. Okay, so what happens as these two lines are parallel. What about this angle? These two lines are parallel and this AB is a transversal of these two parallel lines. So what happens? These are the corresponding angles, right? So that is why if this is x degrees, this will also x degrees. If this is y degrees, this is also y degrees because these two lines are parallel and this is a transversal of this and these are the corresponding angles. That is why these are equal. So from this, what can you identify from these? You observe APQ triangle as well as ABC triangle. So what can you identify from these two triangles? See, in the APQ triangles, what are the angles? X degrees, Y degrees, Z degrees. So what are the angles in the ABC? Those are also X degrees, Y degrees, Z degrees. So from the angle axiom. So what can you say? These two triangles are similar to each other. Yes. So we'll write the similarity of the two triangles. The triangle APQ, which is similar to what? So the A angle is equal to Z degrees. What is Z degrees in the ABC triangle? A itself, right? So A and P. So P is X degrees. What is the X degrees in the triangle ABC? Which is nothing but B. And Y degrees in the Q. Yes, Y degrees in the ABC triangle, which represents C angle. Okay. So APQ, which is similar to triangle ABC. Okay. What happens if two triangles are similar? Their sides are in proportional, right? So we'll write. So this is the side AP divided by, this is a side AB, and you can write PQ side, which is proportional to BC side, and which is equal to AQ divided by AC. Yes, this holds because those two are similar triangles. Now you take these two, you equate these two. Okay. So what AP represents? AP is nothing but it is a part of a side AB, isn't it? And what about AQ? AQ is a part of this AC side. Now this AB is total side and this AC is total side. So from the basic proportionality theorem, we have seen the parts are in the same ratio and the total side and the below part are in the same ratio from the application 1. And now we have seen the above part and the sides, the total side also in the same ratio. Sometimes in the exam, they give the total side value, length of the total side and one part of the side. So that time you can easily calculate the other part and other side, right? So for that it is very helpful. So this is the result too. Okay. Now we'll see what is the third result. So you take one triangle. This is ABC triangle. So this is AB side, AC side. You take the midpoint of AB as well as midpoint of AC. So this need not be equilateral triangle always. This can be scalene triangle, isosceles triangle, whatever may be the triangle. You take always midpoint of the sides. Okay. So this is a midpoint of AB, which is P, and this is the midpoint of AC, which is Q. You join these midpoints. Okay. If you join these midpoints, what happens? This PQ is parallel to BC. So whatever may be the lengths of these sides, you just locate the midpoint of the sides, then join those 2 points. That will always parallel to the third side. So that is why PQ is parallel to BC, and this length of the PQ, which is always half of the third side, which is nothing but C. If PQ is parallel to BC and this PQ length, which is always equal to half of BC. This is the next result from the BPT. So you take midpoints. In the previous case, what we have taken? We have taken any parallel line. Need not be the midpoints, right? So now in this result, we have considered midpoints of the sides. So if you join the midpoints of the two sides, which is always parallel to the third side and exactly half of the third side. So this is also called as a midpoint theorem. We use this result while solving the questions. Okay. you remember the statements, because in the exam they will give you these statements as a options. No, means we need to identify whether the given statement is correct or not. That is why you should remember the statements of the theorems. Okay, this we can also call as a midpoint theorem, because we are considering the midpoints of the two sides. Okay, so this is the result we can obtain from the basic proportionality theorem. The converse also true in the case of this. So what is the converse? We have taken the midpoints of two and we are joining. So we are saying these two are parallel and this is exactly half of BC. So in the next converse of midpoint theorem, what we take? You take any midpoint of one side. You draw parallel to the third side. Okay, you draw one line which is parallel to the third side. So what it does? This line exactly cut the other side at the midpoint. Initially, in the midpoint theorem, we have taken exactly the midpoint. We have joined those 2 points. Then we have obtained the one result. Now, the converse, what we have taken, we have considered only one midpoint. That is P. And we are drawing a line which is parallel to BC. So, initially, we have considered the parallel to BC. So, what it does? It meets the other side exactly the midpoint of the side. So this is a midpoint of a side. So that is the converse of midpoint theorem. What it is doing? It is cutting this side exactly the midpoint, which is nothing but AQ, which is equal to QC. So this result we can obtain from the converse of midpoint theorem. If AP is equal to PB and this is parallel to BC. Then if AP is equal to PB, AP is equal to PB, nothing but we are considering midpoint of AB. So from this, if we draw a parallel line to BC, nothing but PQ is parallel to BC. So these are the given conditions. What we are getting? We are getting which is cutting exactly midpoint of the other side AC, which is equal to AQ is equal to QC. These are the four results we have obtained from the basic proportionality theorem, and these statements are very important. Try to remember. Thank you.